Hi, welcome to our first virtual summertime STEM program at the Red Mag Public Library. You can notice this one is being recorded at my house, but future episodes will be recorded at the public library. Our first theme for this week is all about roller coasters. Before I introduce some videos about roller coasters and the forces of science that make them work, I want to share with you a little bit about the engineering design process, which people use to create inventions and test their work. So I'm going to share my screen and show that to you now. So just hold on one moment. And we're going to go right ahead to here. And this is the engineering design process. There are basically 6 steps. Sometimes there's 5, sometimes there's 7, depending what model you follow exactly. The first one is usually the same. It's ask a question. You have to look around your world and see if there's a problem or something that you don't understand that you want to know a little more about. You ask a question. So my question might be, I'd love to go to amusement parks down the shore to Point Pleasant and to Six Flags A Great Adventure. I wonder what makes those roller coasters actually work. What keeps them on the track? And what gives you that aha feeling in your tummy as you go down the hill? So then after you ask a question, you have to gather some information and imagine some kind of plan, some kind of possible solution. Gather some information about what you know already, and then ask some questions that you may not know that you have to find out further answers to. So I imagine that there's some kind of force pushing the roller coaster down that keeps it steady on its tracks. I imagine that there's another force that gives us that aha feeling in our tummy as we go down the decline. So I know there are inclines and declines in a roller coaster. I know we wear seat belts for safety, especially if there's loops. We have harnesses that go over our shoulders to keep us in and not falling out of our seats. And there's lots of other devices that use brakes, timing, and other safety gear to keep the roller coasters working. The next thing we need to do is devise a plan. So if our task is to try to model and build a design of our own little roller coaster, we need to come up with a plan, and that is your challenge. The plan is also going to be our challenge for the week. And the challenge is going to be to use some materials that you have around your house to design a mini roller coaster using some of the same principles the actual roller coasters use. So sometimes here is where you would have to know the limits of your materials. And for this particular project, we're keeping it very simple. You're going to use cups, plastic or paper cups. You might be able to use cups that are in your parents' cabinets. Just make sure you ask them first. And plastic's much safer than you having kids use glass because we don't want them to break. Mini cups, it said, are good, like the cups you would use for the bathroom, which use mouthwash, or small cups for drinks like that. We had some regular sized cups at the library. You could always use scissors and cut those down, or if you need to make a taller one, you could pile or stack cups on top of each other. And that's to make the inclines for the roller coaster. The other material you're going to need are some fluted paper plates. If you don't know what a fluted paper plate is, it's a paper plate with those ridges along the edges to hold the materials onto the plate so liquid doesn't spill over. We're going to be using scissors and cutting those ridges off the paper plate to be the actual track your marble or other small ball, cotton ball, tinfoil ball, anything like that, Play-Doh ball, can actually go down on the track. You're going to keep the remaining extra parts of the paper plate because you might need to tape them on as bumpers so your marble doesn't fall off the track sideways. That's one of the materials you'll need. You need either glue stick, Elmer's glue, or I'm going to use tape. Actually, I'm going to use packing tape because it's probably a little bit stronger. And then, of course, you need your marble, your tinfoil ball, or your Play-Doh ball, something like that to be an actual object on the roller coaster. So it's really all the materials you need to make a simple idea of how a roller coaster works. You're going to plan that out. When you plan it out, you see that this girl down here is actually drawing and sketching, and that's important. Before you just delve into the actual making it and exploring, you need to come up with some kind of design, and that's usually what a plan is. You sketch it out so you have some ideas, and often scientists will sketch more than one idea because they have lots of things they're brainstorming, and they're not sure at this point which one will work the best. So then you go to the next step, which is create. And this is the part that most kids like the best because it's the hands-on part where you actually get to do and make the project. So you'll be building here and taping and cutting and creating. And then the next step says test and improve. This is where you'd like to maybe have a notebook and keep some records of information and data from the different tests you do. Like, is there a certain point on the ramp of your roller coaster that the ball keeps getting stuck? How is the speed? Is it too fast or too slow? Is there something that you think needs changing? And that's where it says improve. Usually on the first try, things don't go right all the way through. With my students, I learned this acronym called FAIL, and FAIL stands for F, first, A, attempt, I, in, L, learning. So first attempt in learning. If you fail, it doesn't mean you're not successful, you're not good at what you're doing. It just means it was a first attempt and it needs some improvements to make it a little bit better and try again. And that's absolutely how we learn, by making errors and fixing them. So the next step says reflect and present. Reflect means we think back on what we did well, how we worked with team members, if we could have used different supplies, and anything else we might want to change to make improvements next time, either make it cheaper, easier, faster, or better, any one of those. And then you present. And present is where you would either present it to a group of friends, to a class, to your teacher, or to the scientific community of peers that you would have when you're ready to share that idea. And that's what we're going to ask you to do through our Facebook library Facebook page at Red Bank Library, to take some videos or submit some pictures of your work. You can do it in stages. So you can do the first one where it didn't work so successfully, and then you can show another picture or another video of what did work. So that progress is what we'd love to see for scientists. And that, in a nutshell, is the engineering design process. We will be using that same format for all of our summertime STEM activities. So I know it took a while to explain it, but it is super important, as is the foundation of what we're going to continue to do. So the next thing we're going to do is watch a few videos to learn about the scientific principles behind roller coasters. And of course, you're not expected to know all this off the top of your head. That's why we read books and use online resources to do research from people that actually work in the field that can share their knowledge with us. So I'm going to scroll down to a part where it has QR codes and some links to videos about roller coasters from SciShow Kids and one of the other science sites that we use with our children a lot. Just give me a moment. This does a lot of stuff for teachers too. There's a STEM journal to keep a record of all your work. This one was scrolling through. That's a possibility we'll show you of what a finished product might look like. Yours might look very different than this, but that is one example. And here it says explore roller coasters. That's where we need to be. We're going to explore some roller coasters, then we're going to learn the physics. That's the scientific body of study that roller coasters work on. So sometimes it's biology or earth science or chemistry with chemical reactions. This one's forces and motions, which cover the science area of physics. So let's take a look at some roller coasters. Why roller coasters are awesome. I love that title already. We can see these kids are definitely having fun. They're excited, their hands are up. They're ready for a thrill on the roller coaster ride. Here we go. It's about 3 minutes.
Are getting ready to visit the fair. There's one around here every year, and there are all kinds of things to do. You can see lots of farm animals, eat some delicious food, and of course, there are plenty of rides. My favorite ride is the roller coaster, but asking me how roller coasters work, and I thought that was a great question because they're not at all like the cars we drive on the street. Instead, roller coasters have cars that run on a track. And the way they work is the same reason that they're so much fun. Because of forces. You can think of a force as a push or pull on something. That's how you make things move or speed up or slow down. For example, bikes start moving when we put forces on the pedals with our legs, which turn the wheels. And things like cars, planes, and trains work because of the forces made by their motors. But roller coaster cars don't have motors, so the force that starts them moving has to come from somewhere else. Most of the time, the force comes from a strong chain attached to the tracks. The ride starts when the chain pulls the roller coaster cars up to the top of a big hill. But when the cars start to go over the top of the hill, the chain lets go, and the cars keep moving anyway, usually all the way to the end. That's because a different force takes over, one you might have heard about before. It's the force that makes the ball fall back down when you throw it into the air. The force is called gravity. Gravity pulls everything on Earth down toward the ground. And it's gravity that pulls the roller coaster cars down over the hill and along the track. And once those cars get moving downhill, they can keep going. Roller coaster cars that have just gone down a big hill are going so fast that they can get up to the top of the next hill. If they didn't have enough speed, they wouldn't make it over the top. And they would just slide back down to the bottom and get stuck there. The people who design and build roller coasters know just how fast the cars are going to go and whether they will be able to get over the next hill. And if they find out that the cars don't have enough speed, they change the design to make sure the
Notice
cars
they're
will be
using
able to get
math.
over the top. Or they sometimes add another chain in the track to pull them up over the top of the hill. Then, once the cars get to the top of that second hill, gravity takes over again and pulls them down into whatever bend or hill comes next. But even though roller coaster rides can be really fun, they don't last forever. And that's because of another kind of force. This force is called friction, and it pulls on things that are moving, slowing them down. Have you ever tried to slide along the floor in your socks? If the floor is made of carpet, your socks scrape along it so roughly that there's a ton of friction, and you probably won't slide at all. If it's made of something a little more slippery like wood, you might slide a little, but eventually you stop because there's friction when your socks scrape along the floor, slowing you down. The same thing happens with the roller coaster cars. The tracks are slippery enough that the cars can slide along them for a while, but friction is still pulling on the cars, slowing them down, and eventually they stop. So you can use the science of forces to make some awesome rides, but all good things must come to an end. In the meantime, though, we still have a fair to explore. Are you ready, Squeaks? Thanks for joining us. If you want to keep learning and having fun with Squeaks and me, hit the subscribe button, and we'll see you next time here at the fort.
And that was from SciShow Kids, which really brings scientific principles that are pretty difficult concepts into kid language, or even language for Dawn to understand here. So that is absolutely perfect. I want to share one more video with you before I break down the challenge for you to do your own roller coaster. There are several more, and if you're interested in these, you could let me know and I could post them. But this one's called Rollercoaster Physics. And I'm going to click here. We're going to watch this one. And then on our Facebook page and on the library website for the children's page, I'll post some virtual tours where you can pretend you're actually riding some roller coasters, even though amusement parks are not currently open. So this one's called Rollercoaster Physics.
Imagine being strapped into a big chunk of metal, raised over 120 meters into the sky, and then dropped, whizzing over hills and even looping upside down. When you put it that way, roller coasters can seem a little terrifying, but they're also exhilarating and involve some really interesting physics to make all those speedy, gut-dropping thrills work. Most roller coasters start off with something called a lift hill, which mechanically lifts you to the top of the first and tallest hill. But other roller coasters start a little more suddenly. They're rapidly propelled forward thanks to hydraulics, the branch of physics that deals with fluids and how different mechanical forces affect them. Hydraulic launch systems work by using a cable that's attached to two important pieces: the catch car, which connects to the bottom of the roller coaster train, and a giant winch, which is basically a huge spool that winds the cable when it's turned by some motor. So to launch the train, this cable pulls it down the tracks like reeling in a fish really fast. After a few seconds, the catch car releases the train so it can zoom up the big hill. It's kind of a complex mechanism, but we'll go over the basics. The hydraulic fluid and some nitrogen gas are separated by a piston inside this chamber called a hydraulic accumulator. The key to these launch systems is the fact that liquids, like hydraulic fluid, are incompressible. So the hydraulic fluid is pumped into the accumulator and compresses the nitrogen gas. So there's more gas molecules bouncing around in a smaller space, which increases the pressure. Nitrogen gas is cheap, easy to get, and won't react dangerously to heat and high pressure. Basically, no huge explosions. And once the pressure is high enough, a valve is opened and the hydraulic fluid rushes out to power a bunch of motors, which turn the winch, which pulls the cable and accelerates the train. Just like that, within a couple seconds, you're speeding along at hundreds of kilometers per hour. So now that the ride started, you've made it to the top of the first hill, and you start to head over the other side. You might feel something weird, like besides the adrenaline or other chemicals that give you that exciting rush, there's that sinking feeling in your stomach, and you might feel weightless. That's because you're in free fall, meaning that gravity is the only force acting on your body. Normally, throughout the day, you're able to feel your weight because something like the ground or a chair is pushing back on your body, from your feet to your bones and organs. But when you're in free fall, you're not being supported by anything, so there isn't a force pushing upward on you. You're just accelerating toward the earth at 9.8 meters per second squared, like any other falling object. Now, all good or slightly terrifying things have to come to an end, so the roller coaster train needs to stop somehow. Traditionally, roller coasters use brakes that come in contact with a speeding train, like something that skids along the bottom or clamps that close around metal fins on the cars. These brakes rely on friction, which causes the kinetic energy, the energy of motion, to be converted into heat energy and stops the train. And these brakes work, but they get worn out from all this contact. But there are some brakes that don't involve friction. They work by moving a conductor, like the metal fins sticking out from the train, through a magnetic field. A magnetic field can be produced by electric currents, like the currents running through a wire, or the microscopic currents formed by electrons moving within atoms, which is kind of how permanent magnets work. So on the tracks of some roller coasters, there are rows of permanent magnets that create a magnetic field. And when the metal fins pass through the magnetic field, it induces a ring-like current called an eddy current. This has to do with Lenz's law, which essentially tells us that conductors, like metal fins, don't like change. So when the fins enter a magnetic field that wasn't there before, they'll create a current that makes its own magnetic field that opposes this change. The train will slow down because the kinetic energy of the moving train is dissipated as heat by the eddy currents flowing through the metal. And eventually, the train comes to a stop, all without friction. So whether you love them or hate them, hopefully knowing some of the physics behind roller coasters can make you appreciate them a little more. Thank you for watching this episode of SciShow, brought to you by our patrons on Patreon. If you want to help support the show, you can go to patreon.com/SciShow, and don't forget to go to youtube.com/SciShow and subscribe. And over here, closer and further away from this.
Wow, that was amazing. I had no idea about the magnetic field used without friction to stop roller coasters. Next time I'm at an amusement park, I'm definitely going to look at how they're made. So now is our time to challenge you to make your own simple model out of materials you have around the house or can buy at the grocery store. Remember, some of the materials we said we're going to use are those fluted paper plates to cut off the ridges to make for the track of the roller coaster. You can also use the edges or just construction paper to make bumpers to keep the marble or the ball from falling off the sides. Since we are not using any kind of hydraulic fluid to start our roller coaster, we're going to rely simply on the inclines. So our roller coaster is going to start from the top. We're not going to start at the bottom and go up to the top. It is going to start at a high point and just let the gravity pull it down as it goes around. That's your goal for this week. You're going to take some cups, stack them, tape or glue your fluted paper plate like a slide to the cups at different levels and make a spot where it's going to stop. It doesn't have to be super long, just have a hill for it to go down and maybe one twist or turn. We're not going to do anything fancy like loop-de-loops because that will require a lot more complicated science than we have the time or ability to do right now. Let me see if there's anything else I want to show you. Hold on just one more moment. Okay, I'm going to show you a list of the materials you need, a sample of what was done to make one roller coaster, although yours doesn't have to look exactly the same, and then you'll be getting started afterwards. Here we go. So it says roller coaster. You have been asked to design a new roller coaster for an amusement park. Construct a roller coaster that will carry a marble, or if you don't have a marble, remember we said you can use a tinfoil ball, a cotton ball, or even a small ball made out of Play-Doh. And from the top to the bottom without falling off. And the materials you can use are coated paper plates with the lips, the fluted ridgy part around the edges, mini or medium-sized cups, tape or glue, tape would probably work better, pair of scissors, and marbles or your ball. That's all you really need to make this work. Let's take a look at the one design that was given to us before. Here it is. Now, the interesting thing about this is a little bit different than I would have tried it, because I would have turned the cups upside down. But I guess it makes sense because if you look at the one on the bottom, it's a place to catch the ball or the marble. If I had turned that cup upside down, it would just roll to the floor or fall off the table. So you might want to do some upside down and some right side up. Either way. It's just one example of what might work. So give it a try, and remember to post it on our Facebook page. The code word for this week's session, if you're keeping track on Read Squared, to earn points for attending library events, is roller coaster. So please go ahead and type that into Read Squared and get your 50 points for attending today's program. Let's see, anything else I need to show you? I think we're good. This is the last page. Some words to know to review for some of the scientific principles we learned today. And that is gravity. You know about gravity? That's like the ball falling from the sky to the ground. It's the force of attraction of objects to the center of the earth. Friction, if you take your foot and rub it against the carpet or the floor, that resistance you feel that stops you is surface resistance to motion. The friction, the combination. Acceleration is an object's ability to increase speed, to get faster. And momentum is the amount of motion in a moving object, how we can measure it. So thanks for joining us today. I'll be looking forward to your creations. Remember, let's take one last look at the engineering design process of the steps you should take to make your roller coaster. So before jumping in to grab the materials, you should be thinking about these things, asking good questions, imagining materials that you would need and questions that you need answered, and brainstorming in the imagine section. Plan, draw or sketch something out. You can do that on paper, you can do it on a computer. Create is where you actually make and do. Test and improve is say, well, my marble fell off when I was going around this corner. I need to put something up there to brace it to stop it from falling down. Maybe I need to make my incline taller, and try that. Reflect and present. Think about what you did and what you could have done differently. Give yourself a compliment and then some constructive criticism so you can know how to improve and make it even better, cheaper, easier, or faster next time. And present. Present it to us in a video on our Facebook page. Present it to your friends and family. Thanks so much for joining us, and I look forward to seeing you next week for another STEM challenge. Take care.